Hello, AP Environmental Science. This Paul is here. Purpose of this video is to give students an opportunity to fill in any missing notes that they had, or maybe you were absent, to get an opportunity to get those notes. In any event, an opportunity for people who were unable to finish them in class to get them finished. Please don't forget to draw a line down the center of your page. All Cornell notes are done, all class notes are done in Cornell note style, and please make sure to number them. As this is a video and you can pause the video, I will be moving through the slides at a more rapid pace than I do in class. And please, when we get to the whiteboard questions, use that as an opportunity to practice with your notes rather than fast forwarding. Every minute you spend practicing with your notes in class or at home is a minute you don't have to spend studying for a test. All right, here we go. All right, so Chapter 6 deals with saltwater ecosystems. We're going to do some abbreviating. Saltwater is going to be SW, freshwater FW. So obviously the majority of the Earth's water on the surface is saltwater, found in oceans. We're going to abbreviate aquatic as AQ and biodiversity as BD. Capital T, temperature, dissolved oxygen, access to light and nutrients that are needed for photosynthesis. We divide the ocean into the 5 major parts. Obviously, we live next to the largest of the oceans, the Pacific. And organisms are distributed based on salinity, which is the salt concentration is the largest factor. Different organisms have different tolerances to salinity. Getting ready to move ahead in 5, 4, 3, 2, and 1. All right, so aquatic life zones, saltwater, marine. Whenever you see the word marine, it refers to ocean. Oceans, estuaries, coast, coral reefs, mangroves. Estuaries are really important, diverse regions of the planet. That's where fresh water and salt water come together. And you're going to have a variety of species, some that prefer fresh, some that prefer salt, some that can have tolerances for each of the two. Freshwater, lakes, rivers, streams, inland wetlands. All right, so how do organisms get around? They either drift, so they're dependent on the Earth's ocean currents. They're swimmers. They crawl. Of course, that would be along the bottom of the ocean, or they hang on to something like a barnacle and a whale. Some details on drifters. Let's pick 2 of these items. So plankton's a perfect example. Phytoplankton are the most important producer on the planet. That organism alone produces the majority of the oxygen in the atmosphere. They're primary producers. Ultraplankton can also use photosynthesis. Remember, PS stands for photosynthesis. And zooplankton, those are secondary consumers. Zoo means animal-like plankton, so they are predators. And they feed on, obviously, smaller organisms. I'm moving ahead in 5, 4, 3, 2, and 1. What are two factors that affect aquatic biodiversity? Take a look back at number two. Yeah, so we got temperature, dissolved oxygen, access to light, and nutrients. Two examples of saltwater and freshwater life zones. Take a look at number five. This is saltwater, oceans, estuaries, coasts, coral reefs. Freshwater, lakes, streams, inland wetlands. Good. What type or types of plankton is or are producers? Take a look at number 7 for that one. Yeah, so we got phytoplankton and ultraplankton are both photosynthetic or producers. Okay, so swimmers, they're also referred to as nekton. Strong swimmers like fish, turtles, whales. Crawlers, those are along the bottom. Oysters, sea stars, clams. Cleaners, bacteria, barnacles obviously are as well. They're not all decomposers. For example, barnacles are filter feeders. Okay, a new term for you, turbidity. So the more turbid water is, the more cloudy it is. The less turbid water is, the clearer the water is. And turbidity is really important in terms of photosynthesis. So if you have aquatic plants that are on the bottom and the water is really, really cloudy, they're going to get less sunlight, so they're going to be able to produce less. Additionally, as you will learn later in these notes, cloudy water with sediments and solids that are floating within them tend to heat up faster because they absorb solar radiation more than liquids. Solids absorb solar radiation more than liquids. Moving ahead in 5, 4, 3, 2, and 1. So importance of saltwater ecosystems. Major ecosystem services and economic services. They're irreplaceable reservoirs of biodiversity, very, very important in terms of biodiversity. And as you can see from the diagram, lots of ecosystem services, lots of economic services as well. Pick 2 importances of ocean. Most of the rain for land organisms as the evaporation takes place over the ocean, and then clouds move over the land by wind currents. Lots of seafood. If I'm not mistaken, 60% of the fisheries on the planet are being fished at capacity or being overfished. And if coral reefs continue to die, the biodiversity and the fish that they attract, those fish are going to migrate, typically out to the deeper ocean. It's going to be really, really difficult for people that depend on fish and fishing to feed themselves because those fish are going to go away, and many fish species are endangered. It's going to be harder to feed the population. So more than half of the oxygen we breathe, primarily, that's phytoplankton. As we talked about, the bottoms of the oceans are probably an untapped resource for mineral resources, especially rare metal resources, that we'll probably have to explore in the future if we want to convert to green technology. Moving ahead in 5, 4, 3, and 2, 1. Major ocean life zones: coastal, open sea, ocean bottom. So I'm not sure when you're watching this video, but if it's in 2021, we just finished watching the movie Planet Ocean. And as you learned, assuming you didn't already know, the open ocean is owned by nobody. Therefore, it's owned by everybody. Unfortunately, it's poorly regulated, and fishing companies can pretty much take as much as they want. Coastal, obviously, is regulated and controlled by the country or state that it borders. And the bottom of the ocean, very, very similar to the open ocean. As long as it's not near a coastline, it's available for anybody to exploit. Coastal zones, they're warm. It's because they're shallower. Lots of nutrients. So they make up less than 10% of the world's ocean area, but they contain 90% of marine species. And a lot of this has to do with coral reefs. Like I say, coral reefs are habitat for many fish. They're protection for many fish. Lots of fish do their breeding near coral reefs because of the protection. And coral reefs are disappearing at an alarming rate. Primarily to temperature increase within the ocean, and also a decrease in pH because of carbonic acid. I'm moving ahead in 5, 4, 3, 2, and 1. Estuaries and coastal. So river meets the sea, river being freshwater, sea being saltwater. CW, remember that stands for coastal wetland. So they're very moist most of the year. Mangrove forests are very important in terms of erosion control. And also they provide, their root systems provide a lot of habitat and protection for fish species. But they are very rugged shrub-like plants that grow in the water, and they provide barriers from storm surges during hurricanes, and they prevent all the water from smashing into the land and doing more erosion. So they kind of take some of the brunt of those storm surges, and the water does not erode as much of the land as it might otherwise. Really productive ecosystems, lots of nutrients. You can see in the upper image all of that sediment that's coming from the rivers gets dumped into the bay there. Um, and that's also bringing with it a lot of minerals and a lot of nutrients. So these are very nutrient rich areas. I'm moving ahead in 5, 4, 3, 2, and 1. I use this as an opportunity to do a little practice. Is a cloudy liquid more or less turbid? You might want to take a look back at number 9. Yeah, so the more cloudy a liquid is, the more turbid it is. So cloudy is more turbid. 2 reasons ocean ecosystems are important. Take a look at number 10 and 11 for this one. Rainfall, oxygen, seafood, still a lot of potential economic value, also ecological value in the unexplored places, biodiversity, major economic and ecosystem services. All right, see if you can match them up. Which one is a coastal wetland? Which one is an estuary? And if you're not sure, take a look at, take a look at number 14. Yeah, so estuaries are areas where rivers meet the ocean, and coastal wetlands are areas covered with water. All were part of the year. Excuse me, sorry for the yawn. All right, moving ahead. All right, so seagrass beds. So shallow, lots of different species, base of the food chain for lots of other organisms. Intertidal zone is a zone where it's sometimes high tide and it's covered with water, and sometimes low tide and exposed to the atmosphere. So obviously the organisms have to be able to deal with changes in salinity. They have to be able to make sure they don't dry out before the tide comes back. So they're pretty adapted organisms. They need to be able to hold on, as these are areas that get pounded by waves during storms. And there's some organisms that actually burrow or dig and tunnel into the sand. Wetlands. So water most of the year, lots of vegetation. And these plants and animals are well adapted to these conditions. A lot of the areas on the Sacramento Delta are considered to be wetlands. Moving ahead in 5, 4, 3, 2, and 1. Freshwater, saltwater wetlands. There's a little bit of overlap from some information you got earlier in the notes. Swamps, marshes, bogs, prairie potholes are literally what they sound like. It's prairie with a depression, a low spot, and when they get a lot of rain, those fill with water. And frequently, those will turn into vernal pools if they have the right type of wildflowers around them. Saltwater, estuaries, mangrove swamps, coastal marshes, we talked about that. And they provide a variety of ecosystem services. One of the big ecosystem services that these areas do is they absorb a lot of toxins out of the water. So as the water moves into them, it can actually be purified to an extent. Coral reefs are in real big trouble in terms of biodiversity. They are synonymous with tropical rainforests. And they're being destroyed by ocean acidification. Excuse me. And here's how ocean acidification works. So there's an excess of carbon dioxide, obviously, in the atmosphere. So what is happening is that diffuses into the water. CO2 plus H2O creates carbonic acid. So the more carbonic acid, it lowers the pH. Also, as part of that reaction, carbonate ions are consumed, and those are the ions that shell creatures and corals need. Corals need it to build their skeletons. Shell creatures need it to reinforce, strengthen, and build their shells. So if you don't have enough carbonate ions, you're going to have weaker shells in sea creatures. And you're also going to have weaker skeletons in the corals. And then you couple that with a decreasing pH and warmer temperatures, and that spells a lot of trouble for coral reefs. I'm moving ahead in 5, 4, 3, 2, and 1. All right, changes in what two characteristics affect intertidal zone organisms. You might want to take a look back at number 16 for that one if you can't remember. And remember, if you are actually looking these answers up, just pause the video, because I'm going to come with the answer probably a lot quicker than you can find it if you don't remember it. Yeah, so changes in salinity and moisture. Two examples of saltwater and freshwater wetland zones. Take a look at number 18. As freshwater, swamps, marshes, bogs, prairie, potholes. Saltwater, estuaries, mangrove swamps, coastal marshes. Explain ocean acidification destroys coral reef habitats. Take a look at number 20. Yeah, so number one decreases the pH with the addition of carbonic acid reacting with the carbonic acid coming from water and carbon dioxide. Also, carbonate ions are in shorter supply because those are needed in that reaction as well. So lower pH actually dissolves the skeletons of coral reefs, and warmer temperatures in general are bad for coral reefs, and then not enough carbonate ions. Moving ahead. Let me just check one thing real quick. All right, we're still good. Just want to make sure I'm still recording. All right, open sea vertical zones, euphotic. Anytime you see PHO, think photosynthesis. Okay, so euphotic zone is the photosynthetic zone. Sorry, it's the end of a long day. Bathyal, that's the middle zone. Still gets some light, but it's dim. And then the abyssal, that's the bottom of the ocean. Those organisms have to either come up with a way to see in the dark, or they have to use their other senses because that's dark and cold. Euphotic zone, lots of phytoplankton. Low in nutrients because remember photosynthesis requires nutrients. Lots of oxygen primarily because of photosynthesis. And then upwelling brings nutrients from below. And I'll show you a diagram here in a minute that'll kind of give you an idea of how upwelling works. Like I said, bathyal, dimly lit middle zone. It's got zooplankton, some smaller fish. Abyssal, dark, cold, lots of nutrients because remember, everything that dies above falls to the bottom. Low dissolved oxygen, primarily because there is no photosynthesis happening. And deposit feeders are ones that just kind of wait, for the things to fall down from above, and then they go pick on it. Also, a lot of filter feeders because I believe they referred to it in the movie as marine snow. Lots of small particles are floating down from above. And the organisms that live here, some of the organisms that live in this area, have not evolved a whole lot, in hundreds of millions or billions of years. And the reason why we have such ancient prehistoric looking creatures down there is that region doesn't really change much. So organisms that evolve, they evolve and they change to changing conditions, and the bottom of the ocean's pretty much been the same, since oceans arrived. Dark, cold, extreme pressure. So if you're successful billions of years ago, you're probably still successful now. All right, moving ahead in 5, 4, 3, 2, and 1. All right, so here's how upwelling works. And there are a variety of ways, but I like this example because it's really easy to picture this. So if you have a breeze that's coming off of the land, okay, what happens is it pushes this surface water out towards the open ocean, and it creates a void here. And what that does is it pulls water up from below to replace the water that's being blown away from the land. And the nutrients are heavier down here because things are dying and they're falling down. And that brings nutrient-rich water to the surface, and that provides lots of wildlife for the creatures that live near the surface. Primarily, the reason why California has such incredible wildlife off of this coastline is we have a lot of upwelling currents that bring nutrients from the deep up to the surface. Moving ahead in 5, 4, 3, 2, and 1. Okay, so ocean microorganism. This is one of the science focus segments of your textbook. For 2 years, they studied seawater all over the globe. Remember, BD stands for biodiversity. And they identified a whole bunch of undiscovered proteins, which is kind of cool. And they actually figured that there is higher biodiversity in microbial life than they previously thought. Pretty cool information. Human activities obviously influence the ocean just like they do the land. Biggest concerns are ocean acidification and climate change. The climate change indirectly affects ocean acidification. Of course, climate change, there's a lot of carbon dioxide in the atmosphere. More of that diffuses into the ocean, more carbonic acid, less carbonate ion. Coral reefs are dying. And ocean acidification in general refers to the lowering of the pH. Ecosystem services and ecosystems are being threatened, of course. We're really good at putting the hurt on ecosystems. And of course, the services that they do for free for us can no longer occur. Moving ahead in 5, 4, 3, 2, 1. Other human threats. Pick 3 of these. So overfishing, coastal development, basically eliminating habitat, creating more erosion as we're building on the land, removing vegetation. Destruction of ocean bottom habitats. There's a practice in the fishing industry that's called trawling. And what they do is they literally drag a weighted net along the bottom of the ocean to pick up everything that's on the bottom of the ocean and everything in between the bottom of the ocean and the surface. And it destroys coral reefs. It messes up habitats that are on the bottom. It disturbs all of the organisms that burrow down into the sediment on the bottom of the ocean. Trawling needs to be outlawed. Pollutant runoff, ship pollution, invasive species, a lot of similar things to what's happening on the land. Moving ahead in 5, 4, 3, 2, and 1. All right, so core concept in sustainability. They studied some wetlands. They found that temperatures vary due to turbidity. Like I said back at the beginning, the more turbid water is, the higher the temperature typically. And they also found that salinity varies as tides bring salt water into freshwater wetlands. So obviously, you're going to have more salt and a higher salinity when the tides are up. And then it's going to decrease again when the tides move out. But inevitably, every time the tide encroaches onto a freshwater wetland, it's going to leave some salt when it goes out. All right, almost finished. Okay, match these up. Might want to go back and take a look at 22, 23, and 24. As a euphotic is C, bathyal is A, and abyssal is B. So C, A, B. 2 largest concerns related to human activities and the health of ocean ecosystems. You might want to take a look at number 27 for that one. Yeah, so we're most concerned with ocean acidification and climate change. 3 effects on ocean ecosystems related to human activity. Take a look at number 28. At development along the coasts, invasive species, pollution, overfishing, destruction of ocean bottom habitats, and there are many, many more. All right, ladies and gentlemen, that is it for the notes, and I will see you in the classroom.